How to graph y equals the greatest integer of x. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. First of all, we need to recall the definition of the greatest integer of a number. So the greatest integer of x is the largest integer that is less than or equal to that integer x. And that takes a little bit of thought, especially when we get to negative numbers, so hang with me there. So let's look at the greatest integer of these four numbers here. So the greatest integer of 3, by definition, what do you think? What is the largest integer that's less than or equal to 3? And hopefully you said 3. Greatest integer of 3.1. Largest integer is less than or equal to this. I can't go with 4 because 4 is bigger, so I got to go with 3. Notice the answers are integers. 3.5, I know you'd round it to 4, but the greatest integer is still 3. And 3.99, almost 4, but the greatest integer that's less than or equal to it, still 3. Let's look at some negative numbers. This may surprise you here, so be careful. What is the largest integer that is less than or equal to negative 3? Hopefully you said negative 3. Now, negative 3.1, it's the largest integer that is less than or equal to negative 3.1. The answer is negative 4. Because remember that negative 4 is smaller than negative 3. We want one that's less than or equal to this number, and negative 3 would be too big. Now that's the part where people get confused, so think about that. You may need to pause to think about it. What about the greatest integer of negative 3.5? Also negative 4. Negative 3.99. Also negative 4. Think about that. So you'll notice that the greatest integer of any integer is, there's a pattern here. Yes, the integer itself. For example, the greatest integer of 4, of 7 and 10, and even of the negative numbers. But also notice that the greatest integer of any decimal between two integers, not including the endpoints, but between two integers, is always the same integer answer. They have the same answer. So let's look at the greatest integer of 1. We pretty much know that's 1. 1.05, also 1. 1.5, 1. 1.999, 1. That's pretty straightforward. All the ones between 1 and 2, not including 1 and 2 necessarily, have the same answer. These three will have the same answer as well, because they're all between negative 2 and negative 3. Now the greatest integer of negative 2, of course, is itself. But be careful on this one. And it is negative 3. And if that's negative 3, these better be also, because they have the same value in between integers. Press pause as needed to think about that. All right, so let's go ahead and graph the greatest integer function, see what that looks like. So we're going to look at the real numbers between negative 3 and 3. Those will be, I think, the simplest to look at. And we're going to start off knowing that the greatest integer of any integer, again, is the integer itself. So I'm going to plot those. At negative 3, it's negative 3. At negative 2, it's negative 2. Greatest integer of negative 1, negative 1. And so on. At 0, at 1, at 2, and at 3. So those are for the integers, okay? Now, we're not finished. People think, oh, it's a line. Good, this was real easy. No, we haven't looked at the numbers between them. And those are different answers. So the numbers between the integers, Let's start with 1. We know 1 is 1. Greatest integer of 1.05 is 1. So let's go ahead and plot that one. That's over 1.05 and up 1. 1.5 is 1, so over 1.5, up 1. 1.999, almost 2, is 1. We'll plot that one. So in fact, all those numbers will have the same answer, so we're going to get a bar right there, a step, okay, a green bar there. But what happens at this end of the green segment? Is that an open or a closed circle? Well, it is an open circle because the segment stops there, but it doesn't include the endpoint because as soon as I get to 2, greatest integer of 2 jumps up to 2. So it's an open circle. All right, between 2 and 3, well, 2.01 is 2, so we should plot over 2.01 up 2. 2.3, also 2. 2.75, also 2. 2.999, also 2. So we can complete the segment, but what goes at the end of it? Another open circle, because we could jump up to 3. So hope you're noticing the pattern here, and that is this graph is really a series of steps. Left endpoint closed, open endpoint, or right endpoint open. So step between 0 and 1 would look like this with an open circle at the end. Between -1 and 0, another step. Negative, and so we can finish the graph there. So pause is needed. That's what the greatest integer function looks like. It's also known as the step function. Surprise, surprise. Again, notice that the left endpoints are solid and the right endpoints are open circles. That's key. The steps continue up and down infinitely. I think 7 steps is plenty to illustrate what's going on here. So to do this as the greatest integer dance, this is what we'd suggest to graph the greatest integer function. First, plot the solid points at the integers along the line of y equals x, but just points, not the line. So that would be those. Second, we would say draw in the segments or the steps. And third, put the open points on the right endpoints. Not the correct endpoints, but the right endpoints. So let's finally talk about domain and range for this. On the graphing calculator, notice it does not distinguish the open from the closed circles from the picture. It does when you trace, but not from the picture. So the domain is actually going to be all real numbers. Every real number has a y value above or below it, so it is all real numbers. The range is not all real numbers, because those are where the points where the y coordinates are. It's not even close to all real numbers. The range is a set of integers, the positive and negative whole numbers, including 0. So we write that either as a capital script Z or capital J for the set of integers. We encourage you to interact with another video in this series.